Yep, great. Thanks. I'm Tom. I'm from the University of Oxford, and over the past few years, I've been doing a lot of remote and semi-remote monitoring, and I think it's very pertinent to this. I have deliberately left AI in as ambiguous because, of course, we have artificial intelligence and avian influenza shortening to the same thing, and we should actually be aware of that and maybe deconflict it in the literature. I suppose my point is more of a traditional ecologist. I'm not a disease expert, although I do a bit on that. But the summary from the risk assessment for the Southern Ocean is it's here or it's coming. It's not necessarily our fault how it gets there. It seems to be migratory birds that are doing a lot of it. But those of us working at multiple sites, it really could be our fault for spreading it. So the thought experiment here is, what can we do if we can't visit a colony? What can we do that is robust going forward that will collect data without becoming part of the problem? So the first point is drones. Now, there has been a resistance to drones in the seabird community, but there's been an increasing knowledge of, and maybe that's appropriate that we're cautious, but there's an increasing knowledge on disturbance and how to avoid it. We're now doing these routinely all around the Southern Ocean. So for us, for example, this is a classic way. If our biosecurity was poor, if we were going into colonies in the same way that we might at a long-established long-term monitoring site, we could easily become part of the problem. But the kind of surveys we're doing are remote in the sense that we might be very close to them, but they are, we're flying over them. We're getting a lot of detail in terms of colony counts and potentially repeat colony counts throughout the season, just from flying a drone 50 to 60 meters above a colony. There is zero biosecurity risk with this. And what we're doing is, so the gold standard that is easier for penguins, it has to be said, than a lot of cliff nesting birds, or easier for ground nesting, I should say, rather than cliff nesting, is these individual photos become part of a 3D model. And then we turn those into an orthomosaic that we can then count from and is geo-referenced exactly the same between flights, between seasons, between years. And people ask for almost everything we do that is image-based, can AI do that? Can a computer do that? Yes. Ben Weinstein in Florida State has just brought a lot of different species together and trained an AI that works on all of them. I would say it's still not user-friendly, but it's very good. So the final step really is to get this to something that we can do off a PC. Something that, that doesn't need a lot of command line processing, but we're there. We're there at the stage where a really good PhD student who was computer literate could do this, and it's coming within the range of a lot of postdoc skills. The good thing about this is it's been very easy to respond to. So, for example, this is from last week. We sent Nacho up to St Kilda, along with Craig and Ellie Owen. And as you can see here, from previous proper planned surveys that were planned a year ahead of time, we've been able to repeat plots. And we can do like for like with those in response to whatever your question is. The difference here is between visual and thermal. And drones, more expensive now, but drones are in reach that for about 4.5K that can do thermal imaging. So we can do our surveys in thermal as well as in the visible range. And for avian flu, that's very relevant because we could directly determine we could tell the difference between dead and live animals. This is one from Matt and from Sarah Dalrymple, who is showing that it's actually easier to detect cryptic species in in grassland as well. So that difference between the visible and the thermal is quite useful for us to be getting into. Now, this is from Twitter, but the point is that visually in an image, regardless of how that image was obtained, we can detect dead birds. And of course, if that was thermal, that would be even easier by comparison. Certain signs are things we could get remotely. So this is from Maggie, saying that some gannets have been shown to be having bright green feces when they're that arrived coincident with avian flu. In penguins, we get quite a lot of this. We get krill, which means they're being, red poo, which means they're eating krill, white, which means they're eating fish, and green is when they've been standing around for a long time. So this may be something to do with starvation or an inability to leave the nest. But the point is, whether that was via binoculars or by flying overhead, these are visible cues that we could detect from a drone that does not require any biosecurity risk. And I think that's particularly relevant because a lot of what we've talked about so far are the heavily monitored sites where we already have a presence. What are we going to do when we need to go and assess those off-flying sea stacks, those sites that may only be visited once or twice a year? So one of the things I want to get you to take home is video. Drones you can very slowly get to a point where this colony is comfortable with this, but within this video, you can look for these signs of neurological tics, of shaking, of head swaying, head tucking unusually. You will get if there is any bright green poo, and you can also look for dead birds. So there's a couple of, this one is actually shaking. There's a few dead ones in here, the other moves whenever I point at one. But the point is that video is actually something we should be taking now that is far easier for an expert to assess and for you to get a second opinion remotely. Finally, I think we shouldn't really forget all the other stuff we're doing, which is all of these surveys exist within our wider knowledge and the potential to go back in time. For all of these, we know with hindsight we should have started this 5 years ago, be that disease surveillance, time-lapse monitoring, or sensors from drones. But this is one from St Kilda where, because this census was later than it traditionally has been, they've been reaching out on Twitter for like August images of Borroway, so that hopefully we can say, is this thinning out of the colony due to the timing of the census, or is this a real thinning out due to disease? And I should point out that the bottom one there is an August survey from 2 years ago, and the top is August from this year. It was about last week, I believe. So, should you be doing it? How should you be doing it? Well, this is some of Alice Edney's work, and actually some of you that from 2018, the Liverpool conference, contributed to this that we're finally writing up and publishing. A global review of UAV studies shows that if you fly above 40 meters, and some people set the level at 50, you're not going to see high levels of disturbance. That means flushing, things like that. You might see some low disturbance in terms of animals looking at the camera, things like that, until you go up to about 70 or 80 meters. The point is, actually, you shouldn't just be getting in a drone pilot to tell you what to do. It should be within your knowledge of that species and with a good observer that's advising and revising the parameters for these flights. But it is certainly easy now to get good data without disturbing your focus. We can help you with this. The law now, certainly within the UK, is relatively clear. It's actually pretty consistent around the world. There's different levels of bureaucracy, but we can come up with a fairly standard plan for seabird surveys now, and we can actually train you in this. So I'm very much hoping that come February, March next spring, we could help anyone who wants to get qualified in time for the following season, and maybe send people to help you if you're new to this. It basically requires an online course to know what the law is. That will differ between some parts of Europe and between Ireland, for example, but usually an online course. And then some really sensible precautionary measures, which are you're not flying too high, because then you can't interfere with low-flying aircraft. Taking off away from the colony and slowly moving in to assess any response before you're over it or before you may be disturbing it. It's always a pair, so you have an observer with binoculars deliberately looking for behavioral changes before you would create any big disturbance. And very roughly, as a rule of thumb, 50 meters is what you should be looking to avoid. If you're 50 meters or greater away from the colony in either sideways distance or vertical, you should be okay. You're probably more at risk of disturbance in the longitudinal than in the vertical, just because they may be flying further from the cliff. Going forward, I'm a huge fan of time-lapse cameras. Sorry, this is looking terrible. But of course, we could get productivity and survival from quite a lot of these if we had them in place. So I think, again, thinking of what we can do that either doesn't involve us setting feet on the ground or doesn't involve us setting feet on the ground at the time when their colony is there or there's a risk. Because once you have any kind of remote or semi-remote camera, you don't have to go there during the breeding season. It would be fine to change it and have good biosecurity outside of that. A request from a collaborator in Australia is that there's a lot of tools that could be used to bring some of the lab tools into the field. And there's a lot of examples now of lab in a suitcase via the MinION toolkit. There's a development of nano sensing that would be very fast detection of presence or absence and even quantifying within a sample. But I think what I would say is I would defer that to the experts on biosecurity and actually whether we should even be touching birds once we know avian flu is there. I think that's very much one for a smaller subset of experts that could do this safely. So with that, thank you very much. Any questions?
I'm so confident in being able to train people to fly a drone, he's even offered to train me. So.
Yeah, no, I'm genuine about that. I think we can do this, and we need to train seabird experts to fly drones because they already have the resistance to disturbance and things like that. So I think a few well-trained people that were on site or near a lot of these sites would make a very big difference in data collection.
I'll give you the logo for the University of Gloucestershire afterwards.
Oh, shit.
That's all right. Does Amandine have any questions on the chat? Time for one quick question, I think.
There is one. How feasible it is to use drones to survey cliff nesters, and how much does it depend on weather and topography?
I think I'll repeat it. I think the question was, if you're surveying cliff nesters, how much depends on weather, and what was the other thing? Topography.
Yep.
A great deal. There's no doubt that it's easier to survey ground nesting birds on a planar surface. It's harder. You certainly can't automate it because the drone will try and fly into the cliff. We know that people have tried this and failed from the top of a cliff. It's a terrible idea. If you fly from a boat, although that sounds harder, there's no interruption of line of sight on the transmission. So it's far easier to fly, it's far safer to fly from a boat. It needs a lot more care and a bit more experience, but it's totally possible. For the weather, I think that's more, you can definitely fly in snow. I wouldn't really fly in rain. And cloud level is a big problem. So I think, yeah, the challenge is, you can probably fly in weather that is worse than people expect. However, you can't fly in high winds in rain. The topography, I think, is not a big challenge other than you need to build up and get experience doing that slowly. But very much something that, so Nacho, for example, who did St. Kilda last year, he had a couple of years experience in Antarctica, but that was his first time flying from a moving boat, and he got all of the islands done fine. Sorry, from a moving boat in high seas, but it was still pretty bad weather and he got it all done.
Okay, thanks, Tom. Thank you. Get the microphone.